Oh. Kenapa ini ada kursi, kenapa kursi larinya?
Jadiin gua fokus ya. Buat
Cek. Oke, Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome at the presentation in this afternoon, along me and our invited speaker, Professor Raymond L. Chamber. Hello, Prof. Ray. How are you?
I'm all right, thank you. Hello to you too.
I'm fine. I'm great. Thank you. Okay, for the first, let me introduce myself. My name is Vera Maya Santi. I am a lecturer on Statistics Department, Universitas Negeri Jakarta. Okay, ladies and gentlemen, here is the profile video of our invited speaker. Okay, that was the profile of Professor Raymond L. Chamber as our invited speaker in this session. For all attendees, we remind you that there will be a question and answer session at the end of the presentation from our invited speaker. Attendees who want to ask, we welcome you to write a question in the chat room, and don't forget to write your name and your institution. We want to remind you again that Professor Ray's presentation is Nudging a Pseudo, Science Towards a Science, the Role of Statistics in Rainfall Enhancement Trial in Oman. Wow, it is a very interesting topic, Prof. Well, Prof. Ray, the time is yours.
Thank you very much, Dr. Santi. I assume I share the screen now, at least I try. Or maybe I just go up here. I'll share my screen. Let's see what happens. Okay. I think that's the one I want. And okay. Can everybody see the, I hope everybody can see it now.
Yes, it is.
Okay, so the title of my talk, as Dr. Santi has just said, is Nudging a Pseudoscience Towards a Science, which is the role of statistics in a rainfall enhancement trial. Sorry about that, trying to move things around. In a rainfall enhancement trial in Oman. And I basically thought that this might be an interesting presentation given the conference in Jakarta at the moment is about science and mathematics, and statistics is often viewed as a part of mathematics, and mathematics is, as it were, the handmaiden of science, and statistics, if one thinks of it, is somewhat like having the house cleaner around in science. Statistics tries to make sure that science does the right thing. And one of the things I want to talk about today is how it's useful in a science which is not really a science in the sense that it's been labeled a pseudoscience, and how statistics might help in moving it towards more of a scientific basis. So here's the overview of my presentation. I'll talk about weather modification, why it's often called a pseudoscience. Cloud seeding is probably the best known type of rainfall enhancement mechanism used in weather modification. But there are also other types of weather modification, rainfall enhancement techniques. And the one I want to focus on is something called ground-based ionization, which is not always accepted as being a scientific method. And I'll talk about testing ground-based ionizations both in Australia and Oman, and then go on to some lessons we may have learned from that. So what is the aim of rainfall enhancement? Well, as the name says, it's about making it rain harder. Weather modification, according to the World Meteorological Organization, is persistent and recurring changes in local or regional weather patterns due to human intervention. And rainfall enhancement is essentially increasing the amount of rainfall when it actually does rain. Now, the World Meteorological Organization, or WMO, is not too convinced about rainfall enhancement. And this becomes clear when you see their statement on weather modification, 2010, which says effectively it's impossible to create cloud systems that rain. Any technology that claims it can do such things should be treated with suspicion. Augmentation of precipitation, any type of cloud modifications are really still striving to achieve a sound scientific foundation. They're not really scientific. The economic analyses, really, there may be strong economic benefit, but the uncertainties make any investment in these efforts considerably risky. And so there's a need for a lot more strategic research. And perhaps what I'm going to be talking about is really this continuing strategic research and how it might help. So here are the WMO requirements for proper evaluation of a weather modification activity. First of all, you have to have some sort of randomized experimental procedure for deciding whether you actually have increased the rainfall or not. The primary analysis of the data obtained in such an experiment should be based on using objective statistical techniques. And it should really provide an estimate of increased rainfall on the ground and confidence intervals. So some assessment of the true impact of the rainfall increase can be obtained. But also, and this is an important thing I'm going to come back to right at the end, there should be some secondary analyses which basically confirm that the rainfall enhancement actually took place. So they provide physical support for the primary analysis, which is the statistical analysis, by explaining the scientific basis of the statistical result. And because there is a huge natural variability in rainfall, any investigation should be viewed as a long-term commitment. So we're not going to be able to assess these things just by perhaps trying to do it over a week or a month or even 2 or 3 months. This is a long-term, many-year commitment. And this is precisely the type of commitment that actually happened in Oman. All right, just a bit of background in cloud seeding. I think most of you may be aware of the cloud seeding concept, but this is a small graphic which illustrates you have a plane which is flying above clouds. It discharges chemicals, typically silver iodide pellets. These act as nuclei for condensation in the cloud, and this can either come out as ice precipitation or as increased rainfall, called either glaciogenic seeding, when you have ice phase precipitation induced in very cold clouds, or hygroscopic seeding, which is coalescence of water droplets in warmer clouds. And hygroscopic seeding is essentially the focus of the techniques that I want to talk about today. All right, so in terms of cloud seeding, the World Meteorological Organization has an opinion.
I'm sorry, Prof. Ray. Please turn on your mic first. Prof. Ray, please turn on your mic.
Can you hear me now?
Okay, thank you.
Okay, yeah, all right. I don't know what caused that. Could you hear me before?
A little bit. Okay, no problem.
How about now?
You can continue
okay?
that.
Is it okay
It's
now?
okay. Yes.
Okay. So I'm now talking about cloud seeding and the World Meteorological Organization opinion on cloud seeding, which, as you can see in front of you, says, as far as glaciogenic seeding is concerned, there is some statistical evidence, not very strong. I'm not sure. I can hear other people talking as well. Can you hear me?
Yeah.
Okay. There is also seeding of convective clouds with hygroscopic materials, which is not yet an established technology. Okay, so basically, effectively, convective cloud seeding is not really viewed as something that's terribly sensible. Well, there is an alternative to cloud seeding, which is ground-based ionization, and these ideas were initially developed by Bernard Vonnegut at GE Labs in the United States in the 50s and 60s. And he, in fact, was a cloud seeding pioneer in discussing the use of silver iodide in clouds. But he also investigated the effect of electrical forces on droplet collision and growth and advocated the artificial electrification of clouds. Now, he published his work and really that sunk into obscurity. But in the 1980s and 1990s in Russia, a gentleman called Valery Ubo developed what's called the Atlant approach to ground-based ionization using atmospheric uplift. There's very little published work, in fact, none that's not in Russian from this Russian work in the early 80s and 90s. So we have to just look at the technology and see how it works without having any sort of theoretical basis for understanding it. So this is an early Atlant mechanism over here. You can see it looks like a whole bunch of wireframe pyramids. Essentially, the idea, there's lots of wire strung around these pyramids, and aerosols, small atmospheric dust particles, become negatively charged or ionized after exposure to a high voltage corona discharge wire array. So you have very, very high voltages going through these wireframes. Then what happens is these things are placed where there is atmospheric uplift. So you have convection currents, turbulence in the atmosphere, then negatively charged aerosols, which effectively come off this mechanism, are then carried into the cloud layer, where they act as condensation nuclei for cloud droplets. Now, the most important thing is that the electrical charge carried by these new cloud droplets influences their collision and subsequent coalescence into larger raindrops. Now, this is a controversial assumption. and one that many atmospheric physicists probably would not agree with or say would be impossible. But recent research coming out of China has indicated that maybe our models for what's going on are perhaps need modification. So I'll give a reference there to Wang et al. In 2020. In any case, the change rate of coalescence has a significant effect on the amount of rainfall from clouds that are downwind of the Atlant mechanism. Now, the thing with this is that there are people involved in this area who perhaps take advantage of these ideas. And this is an experiment that was carried out in Abu Dhabi in 2011, which claimed to have caused it to rain in the desert. Now, I take those claims with a large amount of salt. And in fact, a prominent meteorologist at the US National Center for Atmospheric Research said it is very sad that rain enhancement by methods that have no scientific basis, or at least have never been exposed to a scientific evaluation, get the headlines. So you can see there are people who are in this area who are perhaps taking advantage of sort of perhaps the lack of knowledge of how these things work. In any case, the Atlant experience in Australia has been somewhat mixed. There were 5 trials of this mechanism in Australia, starting with I would say a proof of concept trial in Southeast Queensland in 2007. And there was very strong opposition to the results from this trial. In fact, there were statements like rainmaker Ian Searle, the father of cloud seeding in Australia, says all the literature you've seen on the technology shows it to be a bogus science, which is why I had that title earlier on. There was another trial, 2008 in Bundaberg, which is also in Queensland. And that's where the Atlant was continuously operated. There was a dynamic target area introduced. There was an attempt to get a semi-scientific assessment of what was going on over here. Then trials 3, 4, and 5 were in South Australia near Adelaide. And particularly the 4th and 5th trial used proper randomized experimental design, a randomized crossover design. They used upwind rainfall to predict downwind rainfall so they can control for the current conditions. And they used something called a random effect block bootstrap in order to assess the attribution. I'll come to that in more detail shortly. But as far as Australia is concerned, that was a dead end. Although there was a consistent, about a 10% enhancement every time they tried these things, there was no interest from the government in Australia to fund further Australian trials, despite the recommendations of an independent scientific review panel. So the technology was marketed overseas, and that brings us to Oman, where the government of Oman agreed to fund further trials in 2012. Now, I'm not sure how many of you are sort of aware or knowledgeable about Oman, but it lies at the tip of the Arabian Peninsula. It's one of the most water-stressed countries in the world. And rainfall enhancement trials using the Atlant system were carried out in the Hajar Mountains of northern Oman. And also in this, between 2013 and 2018, 6 years, and in the southern Dhofar region in 2018. The trials were locally managed. The meteorological data was sourced from the Oman, effectively, Department of Meteorology called DGMAN. And the assessment of the data collected in the experiments was done here at Wollongong by economic consultants and Analyticon, as well as National Institute for Applied Statistics research here. And what I'm going to give you quickly is a short summary of what was found out. So here is a picture showing you the black curve shows you the temperature. You can see between January and December in that part of Oman. And the blue bars show you the rainfall. And you can see that over the summer, which is basically May through September, there's almost no rainfall. There's very high temperatures and almost no rainfall. But there is convective clouds and there is rainfall in the mountains. and that is the most suitable time for rainfall enhancement. This is two pictures. This is showing you Oman. So over here, you can see the Hajar Mountains. They go along the northern part of Oman over there. And this is from the Times of Oman, July 30th to 2020. That's about what, a week and a bit ago. Cumulus clouds active on the Hajar Mountains, leading to isolated rains and thunderstorms. And the cumulative clouds are very, very clear in that satellite photo. So how did the Oman thing go? Well, first of all, there was a startup where there was a proof of concept trial in 2013 just using 2 Atlants and a randomized crossover design. And that was subsequently extended to a 5-year trial, 2014 to 2018. Here's H1 and H2, which are the first 2 Atlants. They're the traditional sort of shapes. This is showing you the deployment of the Atlants 2013 to 2018 in the Hajar Mountains. Now you have over here, the orange circles are rain gauges that were installed. The red diamonds are the various Atlants that were installed in the mountains. And then you have the green diamonds over here, which are the meteorology DG-MAN weather stations. In addition to which, vertical sonic wind profilers, or SODARs, were installed at a couple of the Atlant things to look at, basically, to allow assessment of where the ionized aerosols were eventually ending up. The light's gone off here automatically. I've got to put it back on. Okay, this is a picture showing you can see these are subsequent Atlant models deviating from the triangle model, but all on the same basic principle of ionizing uplifted aerosols. The rain gauges, which you saw in that previous thing, this shows you essentially there were 120 gauges installed prior to the start of the 2013 trial. And that went up to 201 gauges by 2017. You got the deployment of the gauges in 2013 here, and then the eventual extent of all the gauges that were installed by 2017 over there. So there were a lot of gauges placed specifically for the purpose of this trial. I also talked about the DG-MAN weather stations. There were a number of weather stations involved and contributing data to the analysis, and this shows you the ones that contributed over different years. They vary from year to year, basically because of missing data. Not all data was provided by all weather stations in every year, but when available, these are the variables which they tended to have most regularly, which is wind speed, dry air temperature, dew point temperature, relative humidity, and air pressure. Probably the most important thing that was necessary for analyzing these trials was the wind direction. And this was obtained from the DG-MAN radiosonde at Muscat International Airport, which every day gives you data on vertical wind profiles, as well as values of key meteorological indices. And the measurement of steering wind direction and speed is obviously crucial for identifying where an operating Atlant has a rainfall enhancement effect, because effectively any rainfall enhancement has to be downwind. And so you have to know where downwind is, and that is essential in our analysis of the trial data. So there is a 4 a.m., as you can see over here, a 4 a.m. radiosonde every day. It's a standard one. But in addition, in 2015, 2017, and 2018, extra radiosondes were put up just to see how the wind direction changed during the day. In the end, the analysis was done just using the 4 a.m. radiosonde data. Just go back a bit. One of the thing about it, again here, missing data is a problem. You can see that you start off with a reasonable amount of days with data, but in 2017 and 2018, there was a lot of missing data on the radiosondes. They were changing over the system at the airport, and there was a lot of missing data. Okay, this shows you the schedule for when the Atlants were operated. And the only exceptions, there was a randomized operating schedule. It was defined each year before commencement of operations for that year, strictly followed irrespective of weather conditions. It didn't matter whether there was clouds or not, they just ran. The only exceptions are obviously when the machines themselves had issues, and there was missing radiosound data, as I've already talked about. The design of the Atlant operating schedules varied depending on the number of Atlants that were operating that year. So for example, in 2013, there was a randomized crossover schedule. Then there was a randomized paired crossover scheme used in 2014. And then from 2015 onwards, effectively a randomized schedule subject to spatiotemporal balance constraints, which ensure the equal number of operational and non-operational Atlants each day, and no Atlants operated more than 2 days in succession. And any given day, the operation of more than 2 adjacent Atlants in the same day was sort of minimized. The Atlants themselves were switched on and off at 7 a.m. local Oman time. Rainfall, 2013 to 2018. The analysis was done at gauge by day level. There were 122,259 gauge day rainfall measurements over the 6-year period, over 740 days. The average gauge day rainfall was 0.35 of a millimeter, but 92.5% of gauge rainfall values was 0. This is a desert country. So in fact, when rain did fall, which is the average gauge day positive rainfall, there was 4.74 millimeters. In fact, over the 6 years, you can see that there is a dramatic drop in rainfall. These are bubble plots showing you at gauges on the year, the amount of rainfall that was recorded. And the figures over here in red are the average positive gauge day rainfall each year. And you can see it drops as you're going from 2013 through to 2018. And you can see also the drop away in rainfall those days. So not only have you got issues with very little rain being recorded, but also each year there appears to be less rain available, less moisture available in the atmosphere. As far as steering winds are concerned, although the main steering winds are from the northeast, this shows you the wind directions, and they're mainly from north-northeast and east-northeast. Actually, the most rain tended to fall from the south, and that was basically due, we think, well, was associated with monsoonal type fronts coming through. The most important issue as far as analyzing Atlant's concerned is its footprint. Where is the rainfall enhancement effect going to be seen? And so that meant we had to model, or at least try and work out what the Atlant plume was doing. And that was determined by upper level wind directions in the free atmosphere above the boundary layer. So this is where the SODARs came in. And the footprint model that was used throughout the trial was a 75-kilometer long but 30-kilometer wide downwind aligned corridor with origin centered on an active Atlant. So effectively, the assumption was that whatever was going to happen in this corridor downwind of an Atlant. Now, we look at gauges that are in the corridor on a given day. There's target gauges, which are downwind of an active Atlant, at least one. Control gauges are downwind as well, but there are not downwind of any active Atlants. And of course, you look back up the corridor over here, and you have the upwind gauges, which tell you what sort of weather is coming downwind, and therefore has nothing to do with any of the rainfall enhancement. Here's a plot showing you the average target and control rainfall. So here's the control rainfall each year. This is average positive rainfall. Here's the target rainfall. And you can see that target rainfall tends to be greater than control rainfall. There's upwind over here, and this is out of scope. This is things that are not in the corridors. The statistical modeling process itself went through various stages, 4 stages. It used a hurdle type model, which essentially is the thing is you model, first of all, the probability of rainfall happening, and then given rainfall happened, you model the amount of rainfall. So there were 2 models fitted for the amount of rainfall. One was for upwind rainfall, and the other one was for downwind rainfall. So the reason we fitted 2 models this way was upwind rainfall was effectively used as a controlling variable for downwind rainfall. And then the differences between actual positive downwind gauge day rainfall and the natural rainfall predictions which come out of our models were then used to estimate the attribution, which is the key thing, how much rain actually, extra rain fell on the ground. Here's a slide which I'm not really going to spend any time on, but essentially gives you the fairly standard, not very, effectively how we actually got to the attribution. But the main thing about it is the attribution itself is the difference between total observed rainfall and total predicted natural rainfall over the trial period. So we are really saying, okay, we know we've seen so much rain. We use our model to predict how much natural rain should have happened, and then we look at attribution as the difference between them. By the way, the total predicted natural rainfall could be less than the total observed rainfall. So in fact, you could see a negative attribution. The model covariates used in our models, these come from all the various sources that were there, mainly used in setting up the upwind model. And this was then used as to define expected rainfall, which was then used in the downwind as the main covariate in the downwind model, as you'll see. Confidence levels, there's a lot of temporal and spatial variability over here. A random day effect was added to both downwind and upwind models in order to allow for imperfect model specification. A 2-stage block bootstrap sampling strategy was used that also included predicting whether rain occurred or not. Was used to assess the confidence intervals on the attribution. And then finally, a non-parametric permutation test was used again to actually test for causality in the attribution process. Here's the fit for over the 6 years for the upwind model, showing you the estimates and the t-values. Red obviously is highly significant. These are t-values greater than 2, absolute values greater than 2. You can see that all those covariates over there, gauge elevation, wind speed, total totals is a meteorological sort of imminent rainfall type measure. Temp dry 2 is a second principal component of dry temperature. Relative humidity 1 is the first principal component of relative humidity, and pressure 1 is the first principal component of pressure. There were 292 days worth of data for upwind and 1,545 actual gauge day observations over the 6 years. When we come to the downwind model, there are only really 2 main covariates in it, which is the elevation of the gauge, and from the upwind model, the expected rain that we expect downwind. And then after that, you have a whole bunch of indicators for whether the observation is a target observation and which Atlant is it a target for. And then you have 2 interaction terms over here for the very high Atlants, which were basically a necessary and certainly in modeling the 2013 data. There were 488 days worth of data, 4,168 actual observations in this model. And you can see over here, you've got red for H1, red for H2, red for H3, and red for H5. So at least 4 of the Atlants were highly significant in terms of their impact on downwind rain. And but there's also a negative here and a negative there, which means at least H4 and H6, rather than having a positive downwind rainfall effect, appear to have had a negative downwind rainfall effect. So the picture is not as clean as you would like it to be. All right. Now, in terms of actual inference for the Atlant, I said a hurdle type model was used. There was bootstrapping. The bootstrap allows you to assess uncertainty in attribution due to likely alternative rainfall patterns. Here we have plots showing you the bootstrap distributions that were generated. This is for the actual attribution measured in millimeters. This is the relative gauge day attribution in percentages. And there was an overall bit over 16% attributed rainfall due to the operation of the Atlants. The final thing that was done was a non-parametric permutation test for a causal relationship between Atlant operation and enhanced rainfall. And it was based on the null premise that if Atlant operation does nothing to enhance rainfall, then the actual operating sequence should have no impact on attribution. So what you do is you just modify, you play around with this operating sequence, you permute it and calculate each time what the attribution would be as if the permuted sequence was the actual one used, and then look at the distribution of attributions you obtain. And if there is no effect, one would then expect the actual attribution estimate to lie somewhere in the body of this permutation distribution. Well, this is what you obtain. This is the permutation distribution of attributions, and this is where the actual estimate that was obtained. So you can see that you have to use the actual operating sequence in order to get the attribution that was observed. It does matter how the Atlants work. So what have we learned so far? There's huge variability in rainfall data. We need large data sets, and I think I've just illustrated one. Fairly complex analyses, but that means you need deep pockets and long planning horizons to obtain the data. And the Oman trial, I think, provides an example of what is possible in this regard. The other thing, of course, in terms of science is correlation is not causation, but it is an extremely good indicator that something is going on. Replication is an even better indicator, and the Oman government has now incorporated the Atlant technology into its water infrastructure and is carrying out further experimentation, which we will see whether that confirms what was observed in the trial. The trial data themselves are freely available, should be a strong incentive for further research, but it's very difficult, even with very good statistical results, to change what I think is fairly entrenched scientific opinion. And certainly not helped when you have pseudoscientific profiteers playing around, as is in this particular arena. So has the Oman trial been a proper evaluation of the Atlant technology? Well, we've met all the WMO requirements as it's listed over there. The only WMO requirement that has not been met is secondary analyses that validate the treatment hypothesis. That is basically observational data showing the, if you want to call it, the enhancement, the coalescence of raindrops from the ionized aerosols. Nudging against a closed door perhaps here, because as far as traditional science is concerned, statistical analysis itself is never enough. The causal mechanism for the treatment impact should be empirically verified. But that requires direct measurement of ionized aerosols and how they encourage raindrop coalescence in nature. This has been seen many times in cloud chambers, but to see it in nature is very, very difficult indeed. So given current technology, we can't do it, but there is actually a trial going along at the moment in northwestern China, which may in fact come out with some results in that respect. In any case, much of real science actually fails this requirement, even though it's said to be one. This is a quote by, title of an article by Carolyn Johnson in the Washington Post in 2015. One big myth about medicine: we know how drugs work. We don't know, but they do work. Thank you. I'm sorry I took so long. Are there any questions? Hello.
Okay, thank you very much for delivering very interesting presentation, Prof. Ray. Next. Hello?
Yes, I'm here.
Okay, thank you, Prof. Ray. Next, we
Should
will
I?
open... sorry?
Sorry. Should I stop screen sharing?
Yeah, it's okay.
Okay.
Thank you.
All right.
Okay, Prof. Ray.
So stop share. There we are.
Yeah, thank you. Okay, next we will open a discussion session. For all attendants, please ask or directly, or you can write your question in the room chat. Okay, there is no question yet, but maybe I can ask you, Perfect?
Yeah, sure.
Okay. This is very interesting topic, but I'm curious about the influence of the area around Oman.
Yes.
Is there a significant influence of the area around Oman, which affect the rainfall in Oman?
The normal rainfall patterns in Oman, essentially there's monsoonal rain, and that happens at certain times of the year. But in summer, essentially the only rainfall are these convective clouds over the Hajar Mountains. And also in the south of Oman, there is rainfall, also some convective clouds, although mainly ground mist. So in summer, there's really no rain. It's only in winter there's rain. But in summer, generally there's not widespread rain. Some convective cloud that sometimes you get an occasional early monsoon or a late monsoon. I'm not sure 100% which way it goes. But really between about July and September, October, the only rainfall is that which is observed in the mountains. And the attempt is to increase the amount of rain that comes down out of those clouds in the mountains.
Okay. The second question for me, is it okay?
Yeah, sure.
Okay. I'm curious about what kind of sampling method that you use if you want to randomize the ATLAN.
The ATLANs themselves, they were operated on it depended on how many there were, but at the end there were 10 ATLANs in the mountains. Okay, and so the procedure was effectively a Monte Carlo search using among a set of possible experimental designs where every Atlant was there were 5 Atlants on each day, 5 Atlants off, equal numbers on and off. Any Atlant that was on one day had to be off the next day. And also Atlants that were effectively too close together were discouraged. So you had a very large number of potential designs that had this sort of characteristic. And essentially what was done was to essentially search among these designs using a Monte Carlo search in order to find one that had all the requirements you were looking for. But it wasn't a search in any. It was a complete random process, which didn't have any specific sort of set outcome. And the other important thing about it, and this is really important, is the design was set in place before the trial started. So this wasn't a situation where after you see the clouds, you decide whether to run the Atlant or not. The complete operating sequence was defined in April, usually in April or at the latest in May. And from then on, it was followed. It didn't matter whether there was cloud or no cloud, the Atlants were turned on and off and measurements were taken.
Okay, thank you, Prof. Ray. Now, there is a question from chat room. I will read this question for you from Mr. Anang Kurnia. This is my lecturer in University of IPB Um, Thank you for your talk. It is a nice topic. Rain is a source of life. So it is interesting to continue to study, including in Indonesia. But Australia and Oman, I think, have different atmosphere and environment. I'm sorry if I'm wrong. Did different environmental condition in Australia and Oman produce different results of this experiment? Could multi-location test applied for this research? There are two questions for you.
Yeah, no. I think that's a very good question. A very, very good question. It is clear. By the way, the conditions in Australia around Adelaide were quite different from the conditions in Oman. All right. The Oman, those mountains are very high. It is clear that if you have the conditions that operate, that exist in Oman, high mountains, convective clouds forming at the middle of the day in the mountains, with rainfall happening up there, you have, and strong winds, strong uplift. You have the conditions for this sort of technology to work. Okay. A similar sort of thing in Adelaide, but there wasn't high mountains. It's more, there was a prevailing wind coming over the sea towards the Atlantic and then moving things inland. By the way, the Chinese researchers are doing a very similar experiment as we speak, but their ground ionization equipment is currently set up on, essentially on the edge of the Tibetan plateau. So they are looking at the same sort of thing where you have high mountains and you have a lot of uplift, and therefore you have aerosols coming, which you can then ionize and create rain further, or not create rain, enhance rain further downwind. Now, if you go to another area, for example, I gave you the example of Abu Dhabi. It's just desert, or United Arab Emirates. It's flat. There are no mountains. There is no condensation. There are no convective clouds. There's no point putting this mechanism there. It's a waste of time. It's not going to work. It's like throwing seed on a barren ground. Why would you do that? There's nothing there. There's no water. There's nothing. So you got to have the conditions for this to work. Now, which conditions? I think that requires assessment. That's why I said replication is really good. Try this thing out in different areas where it should work. Remember, the hypothesis was you needed uplift, you could ionize the aerosols, but you needed moisture in the clouds. If you have those conditions, then it should work. But we really need to replicate this. This really needs to be done in many different parts of the world before we can start to say, yes, it works. At the moment, Oman, Australia, who knows where next? Well, China next, actually, but we will see.
Okay, thank you so much, Prof. Ray. I'm so sorry because our time is up. I think this is a very interesting topic and valuable for us. And before we close this session, would you like to give a closing statement, please?
Oh, well, a closing statement. I didn't realize I had to have a closing statement. I have no real closing statement beyond like I said, that the object of the conference is to look at the intersection between science and mathematics. And this is one intersection. It's not the standard one, but it is where statistics actually can have an impact. Too often statistics is just used in order to, as it were, polish what is a clear result. Here, there is no clear result. The data are very messy, but statistics is being used to try and bring out something which is almost hidden. There is a hidden effect over here, and we're trying to use statistics to bring out the hidden effect. So in that sense, I hope it may be interesting to people who have listened to this talk, and who knows where it'll go from there. But thank you very much for allowing me to speak.
Thank you so much, Prof. Ray. Stay healthy and stay happy. And for all attendants, please fill out the attendance form on the link. You can get the link from the chat room. The time to fill in the attendance from form is 5 minutes only. And now for all participants,
Oh, Dr.
please turn
Santi,
on.
can I just make
Yes?
this one little point? Just want to make
Yeah,
sure that anybody's
of course.
interested, if
Mhm.
anybody's interested in getting further information, particularly in terms of the report or the data, just contact me. I think
Okay.
the slides will be available. It's got my contact email on it.
Okay, thank you so much, Prof.
It's
Ray.
publicly available.
Okay, thank you. And now for all participants, please turn on your video because we will take a picture from our for our documentation. Please. Once again, for all participants, please turn on your video because we will take a picture. Thank you. And don't forget to fill the attendance form. You can get the link from the room chat. Thank you.
And that's
Yes.
it. Well, thank you
Great.
very much.
Thank you so much, Prof. Ray. Well,
Okay.
ladies and gentlemen, this is the presentation from our invited speaker. To Prof. Ray, we welcome you to continue to join this room and listen the presentation from other presenters.
Oh,
Thank you
good.
so
I was
much,
hoping to.
Prof. Ray.
I
Okay.
was hoping to do
Thank you
that.
so much.
Thank you.
Okay, thank you. Thank you so much. Okay, ladies and gentlemen, now we continue the parallel session. We will listen to the exposure and presenter, sorry. For ensure, I would like to call our presenter, Bapak Joseph Ginting. Is already here or not yet? Bapak
Yes,
Joseph.
I'm already here. Yeah, good afternoon.
Good afternoon, thank you, Bapak Joseph Ginting. And then the second is Ibu Fatona Amini.
Yes, I'm here.
Okay, thank you. And then Bapak Bagus Sumargo. Is it already here too? This is my colleague. Hello, Bapak Bagus Sumargo. Not joined yet? Okay, and then Ibu Aam Amaningsih Jumhur. Not joined yet too. And the last, Bapak Aeng Muhyiddin. Not joined too. Okay. Okay. Okay, Bapak dan Ibu. Let's we see the first video from our presenter. Yes, me?
I'm here, I'm Muhyiddin.
Oh yeah, thank you.
I'm Muhyiddin.
Oh, Bapak Aeng Muhyiddin, thank you so much for joining in this room. Okay, check it out. This is the first video from Bapak Joseph Ginting presentation. Enjoy it.
Hello, regarding our obligation to give our presentations in slide, in video for the conference, here with our presentation today, our titles of research is the J value as the measurement tools of the bonds investor behavioral. This research done by us, both of us, Ibu Dr. Lydia Anggreni, Master of Engineering, and I, Dr. Joseph Ginting. Now we will explain the result of our research. The background of our research is the main idea from the observation from the market in capital market. And in Indonesia and also in other countries. The bonds is this in this discussion is part of the debt securities paper issued by the company or government and sold to investor in order to have a fresh money. the bonds are located in the financial statement of company as a part of the long-term liability side in the statement of financial positions. That's from the accounting explanations. The investor invests their money in bonds instrument for the coupon interest rate and capital gain. So both of those income and return called as the yield to maturity or YTM. The bonds coupon interest for some investor is source of passive income, especially for insurance company or mutual funds or pension funds, where they collected the money from the funds owner and then they manage in capital market. The institution of a pension fund itself and an insurance company are very concerned with the bonds, not only for the return, but also for the risk. The bonds market risk is basically reflected by the volatility of bond price occurring in the secondary market and also demonstrated in the absence of response on price movement as the impact of the change in interest rate in the financial market, either from the central bank or from commercial banks. The changes in the interest rates in both the central bank and commercial banks should indirectly affect the price through changes and yield to maturity or YTM expectations. In this case, YTM has a relationship with the market price of the bonds. In another case, we also have the methods to calculate the bonds price by using present value concept without the interactions with the market demand and supply. That's why we need to create the new mathematical concept in order to have the tools to measure the behavior of bonds investor in capital market. Not only for Indonesia, this risk also can be used for international market because the behavioral of investors sometimes created the speculations conditions that give a negative effect to the country. In our research, we have a research method like this slide. We can see from the left and the right. The first step, we create the equations for a market concept like this on the left side, and the result is MP market price. MP is a market price taken from the price calculation with market concept. Another equations taken from the present value concept, price calculation with present value of cash flow. So the result of the second concept using a present value of cash flow concept is can be seen on the right side. And then after we combine these two equations from a price calculation with market concept and present value of the cash flow, we can have the J value formula as follows. Can be seen below in this slide. P equals to 1 plus YTM and so on. Yeah, this is the equations that we propose to be used in financial sector in risk management or investment decision. So this is the topics what we have to propose and test it. And then in research, this formula, these equations already tested by using some simulations. What are the simulations here? The first is we calculate the J value when YTM equals to C, and then we measure the J value when YTM increase above 100 up to 200 basis point above coupon rate. And then the third one is the simulation when YTM decrease 100 up to 200 basis point below coupon rate. Why 100 and 200? This is our simulation, so there is no previous research about this. but I'm sure that 100 basis point or 200 basis point can reflect another changes, decrease or increase. From three simulations above, we can see that the formula or equation is effective to be used as the tools to measure the behavioral of bonds investor. Why? First, the J value is not in straight line, and the number of the tables shows us that the J value does not create the linear line. Number two, even the calculation when C equals to YTM, we can see that the price at maturity is not 100%. The result is 99.65%. Means that the speculations happen even when C equals to YTM. Our analysis is strengthened by using simulation when C is above YTM or C below YTM. C is a coupon rate, and then YTM is yield to maturity, where the J value is in a straight line. Number four, finally, we can summarize that the J value is proven and eligible to be used. From our discussion below, we can take the conclusions as follows. The first, the J value can show that the bonds market price move irrationally during the periods between issuance date and maturity date, especially when C is above YTM or C below YTM. So the speculation is there, and then can be detected by using J value. The J value shows us that when interest rate in the market move, then YTM move irrationally during the period's issuance date and maturity dates, especially when C is above YTM or C is below YTM. So from point 1 and point 2, and then after supported by the discussion, we do believe that the J value is valuable and then can be used by fund manager, by investor, by analyst to read the market risk of bonds in the trading day. So finally, we can say that this J value most probably can help the capital market to stabilize the conditions of macroeconomy and also financial sector. Thanks for watching.
Okay. That was the video presentation from Bapak Joseph Ginting. Is there any question for Bapak Ginting? You can ask directly or you can write the question in the chat room. For all attendants, please ask directly or you can write the question in the chat room. Any question for Bapak Ginting?
No questions. Thank you. Because maybe this is the first because this is about the economic and financial sector. Maybe most of participants here coming from MIPA, mathematical and statistical.
Yeah, maybe Bapak Ginting.
It's okay.
But this is very interesting topic too. It's valuable for us. Thank you.
This is applied statistic for economic financial. Thank you.
Yeah. Yes. Thank you. Okay. Because there is no question for Bapak Joseph Ginting, now we continue to the next video from Ibu Fatona Amini. This is the video presentation from Ibu Fatona Amini. Enjoy it.
Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, thank you for having me. Let me introduce myself. My name is Fatona Amini and I'm from Polytechnic Statistika STIS. And now I'm going to presenting about the comorbid of chronic kidney disease patients who are undergoing dialysis in Indonesia using first logistic regression. In this presentation, the outline will be present is about introduction, methodology, result and discussion, and conclusion. Okay, let's get started from introduction. The background from this paper is from the third goal of SDGs is to ensure a healthy life and create prosperity for all. Health is very important so that humans can move and survive. Healthy individuals are expected to be qualified human resources who play a role in development to realize the welfare of the people. The facts show that there are new challenges in the world of health, namely the occurrence of changes in disease patterns that are becoming increasingly complex due to the impact of social and economic changes. In Indonesia, also the case of non-communicable disease increased significantly over time, and Indonesia is also in a phase of epidemiological transition where the mortality due to the NCD or non-communicable disease continues to increase, while the death from infectious disease are declining, and this phenomenon is predicted to be continuing. According to the result of Riskasdas 2018, NCD prevalence increases compared to the result of Riskasdas 2013, including cancer, stroke, CKD, diabetes mellitus, and hypertension. And one of them is CKD increased from 0.2% to 0.38%. And the next is urgency of the CKD. CKD is one of the risky and very dangerous disease and also called as silent killer. And next, the disease is difficult to cure in a short time, so the cost of treatment and care is expensive. And then sufferers in the last stage of CKD are very dependent on dialysis. In Indonesia, the number of patients who are undergoing dialysis from 2007 until 2017 increased by 70 times. And this disease can be suffered by anyone, not knowing age of the patient, young, adult, or elderly. And based on the Riskasdas 2018, more than 50% of these CKD patients are covered by productive age group. The productive age groups will be able to be the main capital in the development of a country, and if it is not anticipated, it could have an impact on the reduction in human resources, and therefore, need to know the measure about the condition of prevalent CKD in Indonesia, so that the prevalence of CKD can decrease and the death due to the CKD will be reduced and even be eliminated. So based on the phenomenon, this paper is have an objective is to find out the variables that affect someone suffering from CKD who undergo dialysis in Indonesia in 2018. And next is some literature review that used in this paper is from Lebov et al., Sutopo, Ariva et al., Shimamura and Permana, and Peng et al. Next, methodology. The analysis unit of this study is the Indonesian population aged 15 years old and above then suffering from CKD. Riskasdas 2018 is the secondary data that used in this study. The total number of samples used in the study is 2,141 samples, and the method using in this study is first logistic regression. Next is about research variable. There are 7 independent variables: diabetes mellitus status, hypertension status, heart disease status, sex, age, consumption of fruits and vegetables, and consumption of salty foods. They are each suspected to affect the status of having dialysis of patients with CKD. The next is about regression of imbalance data. Imbalance data will produce inaccurate estimates if it is still forced to be analyzed using conventional binary logistic, the conventional logistic regression, use maximum likelihood to estimate the parameter. The maximum likelihood estimate method is not appropriate for imbalanced data. It will cause a bias estimation. So this study used a first logistic regression to reduce the bias resulting from the small sample of maximum likelihood estimate in their even data. One of these method was found by Ford and known as Ford method. This Ford method used a penalized likelihood equation to estimate parameters. And the next is about the steps for analyzing using Ford logistic regression. First, estimating parameters with penalized likelihood. Second, testing the significance of parameters. Third, partial significance testing of parameters. And fourth, testing the suitability of the model with Hausmann-Lomachenko test and classification table. Next, about result and discussion. Table 1 shows that the result of processing partial test using Ford logistic. And this table 1, it can be concluded that there are 5 out of 7 independent variables that significantly affect the status of undergoing dialysis in patients with CKD, which is diabetes mellitus status, hypertension status, sex, age, and consumption of fruits and vegetables. The heart disease status and consumption of healthy foods do not significantly affect the status of undergoing dialysis in patients with CKD. And next, there is a third model that used in this study. At X1, X2, X4, X5, X6, the independent variable that significantly affect the status of undergoing dialysis in CKD patients. Next, goodness of the test. Based on the result of the Hausmann-Lomachenko test, the value is 0.6761, and the value is greater than the alpha, so the decision is failed to reject null hypothesis. It means the model used is fit and are appropriate in explaining the response variable. And the last is about conclusion. Indonesia is in a phase of epidemiological transition where mortality due to NCD continues to increase, while deaths from the infectious disease are declining. Non-communicable disease tend to increase significantly over time. According to the result of PISCAJAS 2018, NCD prevalence increased compared to the result of PISCAJAS 2013, including cancer, stroke, chronic kidney disease, diabetes mellitus, and hypertension. Next, variable that significantly affect the status of undergoing dialysis in patients with CKD in Indonesia are status diabetes mellitus, status hypertension, sex, age, and consumption of fruits and vegetables. CKD sufferers will have a greater tendency to undergo dialysis as sufferers of CKD with the characteristics of suffering from diabetes mellitus, suffering from hypertension, female, young, and lacking in fruit and vegetable intake. Okay, that's all about the presentation. Thank you for all attention, and Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. This is a very interesting topic and presentation. Thank you for Ibu Fatona Amini. Is there any question for Ibu Fatona Amini? Please. For all attendants, Bapak dan Ibu, if you want to ask something to Ibu Fatona Amini, you can ask directly or you can write your question in the room chat. Is there any question? Okay. There is a question from Prof. Ray to Ibu Fatona Amini. Let me read the question for you. How were sample design effects allowed for? Ibu Fatona Amini, you can answer in 2 minutes. Thank you.
Okay, thank you for Provi Ray Chambers for the question. I tried to answer in my question and in your question for the design effect. I don't know about using design effect in this method, but maybe in other research there are some design effect used in research like this. And sorry, I don't know about if the sample design effect is allowed in this in my research. Okay.
You have time. Maybe you can add another answer.
I think enough. And thank you.
Okay, thank you, Ibu Fatona Amini. Okay, we move to the next video presenter from Ibu Velia Aida.
Assalamualaikum warahmatullahi wabarakatuh. Good morning, the committee and participants of the Second Science and Mathematics International Conference 2020. In this occasion, I would like to present my theme paper with the title, The Two-Stage Least Square Simultaneous Equation Model for Panel Data on Human Development, Economics, and Environmental Quality. Before I start this presentation, let me introduce the corresponding author of this paper. First, Mr. Bagus Margo from Jakarta State University, and me, Velia Aida from Statistik Indonesia, Mr. Mulyono and Ms. Siti Rohimah from Jakarta State University. Okay, let's get started. The first part is introduction. We will talk about sustainable development. Sustainable development has 3 dimensions that are interrelated. They are economic, environment, and social. The balance of them is very important for sustainable development. The better quality of environment, the less social problems, for example, health. And the good social condition of social will support faster economic development. For example, high levels of health and education increase labor productivity. This explanation indicates that economic development is closely related to environment and social problems. The sustainable development in Indonesia has not been fully implemented properly. Below are the examples of unbalanced three-dimensional condition in several provinces in Indonesia. Therefore, we conducted this study with the goal of finding out the simultaneous relationship between SDGs dimension in Indonesia and the factors that influence. The second part is methodology. We use secondary data that we get from Statistik Indonesia and Ministry of Environment and Forestry with the research object 33 provinces in Indonesia and time range from 2013 until 2017. And to answer the question of research, according to Gujarati and Porter, the analytical methods that appropriate is simultaneous. So we use two-stage least square simultaneous equation model for final data. There are 7 steps that must be done, and this is the result of equation that we have built. There are 3 equations with 3 endogenous variables and 5 exogenous variables. Each equation represents 1 dimension. The indigenous variables are Human Development Index, GDP per capita, or we call it economic growth, and Environmental Quality Index, while the exogenous variables are poverty rate, high school participation rate, labor force, foreign investment, and population. Next, we go to the general description. These three pictures show that the three dimensions of sustainable development in Indonesia are not yet balanced and do not support one another. For example, in Yogyakarta, it has bad environmental quality, low GDP per capita, but Yogyakarta has a good condition in human development. And then we go to structural equation estimation result. There are three equations that we get. And first, we will look at the simultaneous relationship between the three indigenous variables. From first equation and second equation, we can see the relation between Human Development Index and economic growth from this number with positive direction. There was a significant positive simultaneous relationship between economic growth and human development. Economic growth is one of the important factor as a people's income, as seen through the GDP per capita indicator. The economic growth provides a high level of income as a condition for meeting basic needs and improving the quality of human capital. The higher population expenditure causes the better fulfillment of basic needs of the population, increasing in consumption of goods and services related to Human Development Index components, such as for education and health, so that it affects the Human Development Index in a region. Human Development Index is one of the important factors in economic growth. Quality human resources have the high productivity so that they can improve the efficiency of economic activities and in the aggregate can influence economic growth. Then in equation 1 and equation 3, we can see the relation between human development and environmental quality from this number. Environment quality and human development have a positive simultaneous relationship. Damage in the quality of environment can reduce welfare. This happens because environmental damage causes a decrease in the level of productivity of natural resources and raises various health problems. This means if an increase of air quality, water quality, and land cover quality, then the fulfillment of basic needs will increase and vice versa. The better socio-economic condition, or we can call high human development index of a region, the region environmental awareness is also good. Then in equation 2 and equation 3, we can see the relation between economic growth and environmental quality index from this number. Economic growth cannot take continuously because of environmental constraint. If you want to increase economic growth, it will also increase exploitation and pollution, always returning to the environment. This confirms that the environment is becoming a negative externality of economic growth. Based on Economic Kuznets curve, Indonesia is still in the first stage because economic development in Indonesia is still followed by environmental damage called pre-industrial economics. Next, we will discuss about the exogenous variables. From the first equation, the exogenous variable that influence human development index is poverty rate in opposite direction, negative or opposite direction. The results of Ginting research say that the higher of the population of poor will depress human development. Because the poor have low purchasing power, even though public purchasing power is one composite indicator of human development index. And in the second equation, the exogenous variables that influence significantly to economic growth is foreign direct investment in positive direction. Hala, Abu, and Yasmin in 2011 said that foreign direct investment is one of the macroeconomic aspects that support economic growth. Foreign investment is needed to accelerate economic development, especially for developing countries like Indonesia. And the third equation, the exogenous variable that influence significantly to environmental quality is population in negative or opposite direction and foreign investment from positive direction. And if the population growth far exceeds the resource availability, there will be a massive depletion of natural resources to meet the needs of human life and will lead to higher environmental pollution due to both production and consumptional process. And foreign investment was hypothesized to have a positive environmental impact because multinational companies often have technology that is more efficient and cleaner. This hypothesis is called the halo effect or pollution halo hypothesis. The conclusion that we can get from this study is first, the implementation of sustainable development in Indonesia has not been well, especially on economic and environmental relations. The second, increasing green investment and controlling population growth can be one solution to the problem. And the last, the implementation of sustainable development in Indonesia depends and is supported by quality human resources. That's all from me. Thank you for attention and sorry if there are many mistakes. Wassalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam
warahmatullahi wabarakatuh.
Okay, that was the video presentation from Ibu Felia Aida and team. Is there any question, Bapak dan Ibu, for Ibu Felia Aida? Please, you can ask directly or you can write your question in the chat room. Thank you. Is there any question?
Yes, Ibu. I have one question for her. Can I?
Okay.
Okay.
Please, Bapak.
Yeah,
Just from your video first.
Yeah, I am first. If you look at the third equations, you've shown us that the adjusted R square is 47.80. Don't you have a problem to summarize something from this adjusted R square? Because it is below 50%.
Mm-hmm.
Thank you. That's the first question. You may answer my question, please.
Okay. Ibu Felia Aida, you can answer the question from Bapak Joseph Ginting. You have 2 minutes.
Thank you for the question for Mr. Joseph Ginting. I want to answer about the third equation that has adjusted R square below 0.5. It can happen because environmental quality index has 3 aspects. There are land cover, air equality, and water equality, while in the X variable, the other variable like foreign direct investment and the population. So the R square are below the 0.5 because in population and foreign direct investment, there's no relation with the air quality and water quality.
Okay.
Okay. You still have time to answer the question? Or that's enough? Ibu Felia Aida?
That's enough.
Okay, thank you. To Bapak Joseph Ginting, I hope you satisfied for the answer from Ibu Felia Aida. Okay, now we move to the next video presentation from Bapak Aeng Muhyiddin. Please enjoy it.
Good afternoon, everybody. Thank you for your attention. In this time, we will present the effectiveness of instructional video on student performance. Result of research from Basuki Wibawa and Aing Muhyiddin. This time, my name is Aing Muhyiddin. Introduction. You know that during COVID-19 pandemic, the use of computer in learning result in recommendation for the use of multimedia content like video for effective learning. Video worksheet example demand greater cognitive load. You know, the effectiveness of instructional video depend on instructional design. In this research, we want to comparing the effectiveness of worksheet example video and follow analog learning task and worksheet example video follow completion learning task. In this research, we use conducting quasi experiment between subject design, three conditions like beyond figure. One video worksheet example with attention focusing guidance with analog learning task. Two condition video worksheet example without attention focusing guidance follow analog learning task. And three condition video worksheet example with attention focusing guidance and completion learning task. Measurement with test assessment with rubric. One, accuracy of data structuring. Two, accuracy of interpretation of normality t-test. Three, exposure to the data outreach test interpretation. Four, accuracy interpretation of homogeneity test. And five, the accuracy of the independent sample t-test. Result, was a statistically significant difference between group as determined by one-way ANOVA. F-test 2, 77, 0, 549, and p-value 0, 603. Benporani post-test hoc revealed there was no statistically significant difference between video worksheet example with focusing attention guidance and following task and log, and video worksheet example without focusing attention guidance follow task and log. P-value 0.969 between video worksheet example with focusing attention guidance follow task analog, and between video with focusing attention guidance p-value 0. We assume in this result we assume that the group that receive example worksheet example with focusing guidance and analog assignment, analog learning task was superior to the other two groups. But the evidence of that there was no difference in meaning learning outcome between three groups. This result proved that worksheet example is much more effective in generalization, whatever prior with analog or completion test, and whatever attention focusing guidance or not. As a result, that outreach conducted by Pankok et al. In this result, we know that this principle of segmenting of material, video instructional, and granting access to the right information in the worksheet example guide video are the main principles that are proven to reduce cognitive burden or cognitive load of students, regardless of the guidance given by the consideration. Conclusion, the result of this study contribute that instructional video can be used to transmit conceptual knowledge mental model, as long as the information presentation follows step problem solving, like statistical testing. As stated by Van Meerenbauer and Kirchner, that cognitive strategy and mental model are distinct and inseparable and mutually reinforcing. With instructional video, you know that mental model can construct by a student that is effective whatever attention focusing guidance or not. The result also saw that Worksheet example video have proven to be effective in transmitting conceptual procedural knowledge content, which cannot be generalized given the design of quasi-experiment using existing class without randomization, reducing the validity of test results. I think that is my presentation. Thank you for your attention and bye.
Okay, thank you so much. That was a video presentation from Bapak Aing Muhyiddin. Yes, Bapak Aing Muhyiddin. Is there any question for Bapak Aing Muhyiddin? For all participants, you can ask Bapak Muhyiddin directly, or you can write your question on the room chat or chat room. Is there any question for Bapak Aing Muhyiddin? No question yet. Bapak Aing Muhyiddin is already standby to answer the question, but there is no question yet from another participant. Okay, because there is no question. Okay.
Thank you for.
There is a question from Prof. Ray again. The question is, this is the question from Prof. Ray, sample size for group. Okay, Bapak Aing, you can answer directly the question from Prof. Ray Chamber. Sample size for group. The question is sample size for group.
Thank you for your attention. From Prof. Ray, we use IT sample 35 in experimental group and 45 in control group. We use existing class. Totally 80 students in group, and on group of grup ketiga berjumlah 20. 20.
20, what kind of subject? 20 subject on the group 3?
Yes.
Okay. Okay. That's all?
Yes.
Okay, thank you for your answer. Maybe, I hope Prof. Ray satisfied from the answer from Bapak Aing Muhyiddin. And now, we move to the last, but I hope not the least, video presentation from the last presenter, Ibu Siti Rohma Rohima. Please enjoy it.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, everyone. I would like to say thank you for having us in SMIC 2020 presentation. My name is Kori Medianingsi. And first of all, let me introduce my other group members. First, we have Mrs. Siti Rohmah Rohimah as a lecturer from Study Program of Statistics, and also Ahmad Shauki and Nabila Ninda as students for our Study Program of Statistics. So, instead of the focus of the topic in this opportunity, I'd like to present about the background of the study. And the title of our study is Analysis of the Factors Causing the Number of Poor People in DKI Jakarta using Special Autoregressive Poisson Model. So, first, please move to the background of the study or introduction. So, I will explain about the background of the study concisely. As we know, poverty is still one important aspect of developing countries, including Indonesia. In Indonesia, poverty alleviation is one of the main priorities of national development, as stated in the official National Medium-Term Development Plan, or RPJMN document for 2015 to 2019. In line with the Indonesian government's program, the DKI Jakarta government has formed a Poverty Reduction Committee since 2002, but DKI Jakarta's poverty rate over the past decade has tended to stagnate at around 3 to 4%. Efforts should be made to accelerate poverty alleviation as an end goal, because poverty is a shared responsibility. Based on this phenomenon, this study aims to determine the factors that influence the number of poor people in DKI Jakarta province by considering spatial elements. Spatial effects are common among regions, that is, the number of poor people in one region is influenced by the surrounding area. As the first law of geography put forward by Tabler, everything is related to everything else, but near things are more related than distant things. Therefore, we conducted an analysis using the Spatial Autoregressive Poisson, or SAR Poisson model, to see the factors that influence the number of poor people in DKI Jakarta province. We hope this research will be useful for conducting policy analysis in poverty alleviation, especially in DKI Jakarta. So, it is the background of our research that conducted, and for next step, we will explain about the methodology. It will be presented by Ahmad Shauki, a student of Study Program of Statistics.
Thank you, Ms. Curry. As we know that probability density function of Poisson is like this. And if we build Poisson regression model, the model is like this. If correlation spatial factor is added to the model, so PDF become to like this. And the model is become to Y equal to A inverse X beta plus epsilon star, where A equal to matrix identity minus rho W star, where W star is spatial contiguity matrix, and we in research we use nearest neighborhood contiguity matrix, and rho is spatial correlation. Method. Estimation of rho and beta parameters in the Poisson-Sachs model use iteration with Newton-Raphson method. The stage of Newton-Raphson method are determine beta star hat 0 with beta star 0 like this. That is iteration when t equal to 0. To determine gradient vector G accent t plus 1 is equal to the factor like this, where t is number iteration. 3. Determine Hessian matrix H. 4. Enter beta star hat 0 into G vector and H matrix so that obtain G0 and H0. 5. Set the iteration count t equal to 0. Beta star t plus 1 equal to beta star t minus h inverse t g accent t. Update the solution vector beta stars t. 6. Calculate the error in the solution as the norm of the vector. If the error is small, then stop, or instead set t equal to t plus 1 and goes to step 2. After we obtain the parameters, so we will test the significance of spatial correlation coefficient with word test for rho, and the hypothesis testing for rho is like this. And we will testing for beta with chi-square, and hypothesis testing for beta is like this. And the next presenter is Ms. Siti Rohma Rohima.
Okay, thanks for the opportunity for me and the result and discussion for our research. As we know that the initial step used in the study was to analyze all variables, use descriptive statistics, and we will see the descriptive statistic on the table. Based on the table, we will see that the number of poor people in DKI Jakarta is still high. So our research is conducted in in DKI Jakarta. Before we analyze, use SAR-Poisson model, we conducted the pre-analysis. For step 1 is Kolmogorov-Smirnov test. As we know, the purpose of the Kolmogorov-Smirnov test is to determine whether data on the number of poor people in DKI Jakarta without Kepulauan Seribu follow the Poisson distribution or not. Based on the Kolmogorov-Smirnov test, is obtained that the distribution of the number of poor people in DKI Jakarta has the Poisson distribution. Okay, next, after the Kolmogorov-Smirnov test, we conducted the multicollinearity test, and based on the multicollinearity test, is obtained that there is no explanatory variable has not high collinear. So we can use the Poisson regression model and SAR-Poisson model will be conducted to this research. And please the next slide. The first analysis, we use regression Poisson model, and we obtain the result of the Poisson regression model. We will get the estimate like this, and estimate for all parameter is all significant, and we obtain Poisson regression model like this. 3 variables are significant for the model. and we can interpret from the model that each additional 1% of household with no toilet facility, or as mentioned as X1, can cause the expected value of the number of poor people in DKI Jakarta to increase by exponent to the power 4.478 a to the power minus 1 is can be approximate by 1.565 times, assuming other variables are fixed. In other words, we can say that every 1,000% increase in the variable x will increase the number of poor people by 1,565 people, assuming the other variables are considered constant. After the model Poisson regression is analyzed, the next step, we obtain estimation for Sarr-Poisson model, and the table show all estimate for Sarr-Poisson model. Analysis of the Sarr-Poisson model in DKI Jakarta province so that the number of poor people was affected by the proximity of the region and some significant explanatory variable. Based on the table above, so the significance of each parameter estimator using the WALD test, and we can see that the spatial correlation value is significant. The result obtained by the value of spatial correlation is equal to 0.1, and as we know that the significant value, we use alpha is equal to 5%. Thus, it can be concluded that the number of poor people in a nearby region or location will affect the number of poor people in the surrounding area. And significant test for each parameter, estimator beta 1, beta 2, and beta 3, obtain the value of WALD statistic is also significant. This shows that X1, X2, and X3 included in the model are significant. Based on the above table, so that the model that each addition of 1% to a significant population can cause the expected value of the number of people to increase by exponent to the power 3.49792 exponential to the power minus 8 can be approximate by 1 time, assuming other variables are constant. In other words, every 1,000 additional people will increase the number of poor people by 1,000 people, assuming other variables are considered constant. The next slide will be presented by Nabila Ninda.
Okay, in the last our presentation, I'd like to tell you the conclusion of this research. The conclusion is analysis of the Poisson SAR model in DKI Jakarta province showed that the number of poor people is affected by the proximity of the spatial and non-spatial factors, significantly influencing the Poisson SAR model with an alpha of 5%. The addition of spatial correlation factors gives a smaller standard error value. Okay, thank you all for listening and give your attention to our presentation. May all that we have shared be beneficial for all of us.
Okay. That was the video presentation from our last presenter and team, Ibu Siti Rohmah Rahimah and team. And for the audience, Bapak dan Ibu, you can ask the question directly or you can write a question from the group chat. And okay, there are 2 questions here in the chat room. I will read the question for Mrs. Siti Rohmah Rohimah and team. The first question from Bapak Agus Sumargo is this article to discuss about transient poverty because the type of the poor in DKI Jakarta have more transient poverty communities. And the second question from Prof. Ray Chamber, standard errors in SAR model fit are essentially 0. Is it due to definition of W? That are 2 questions. That are 2 questions from Bapak Agus Sumargo and Prof. Ray. Okay, Ibu Siti Rohmah Rohimah and team, you can answer the question directly. You have 3 minutes to answer the question. Please. Ibu Siti Rohmah Rohimah, Ibu Kori, are you still there? Ibu Siti Rohmah or Ibu Kori? Okay, maybe the signal. So Ibu Siti Rohmah and Ibu Kori cannot join in this room anymore. I'm so sorry to Bapak Bagus Sumargo and Prof. Ray because Ibu Siti Rohmah and team cannot answer your question. Okay. I think this is the end of our conference. And before I close this conference, let's we move to the photo session. For all participants, please turn on your video because we will take a picture for our documentation. Oh, this is Mrs. Corey. Miss Corey? Miss Corey, can you hear me?
Okay.
Okay. Hello.
Okay, please write in this chat. Sorry, because my internet is unstable.
Okay, Ibu Siti Rohmah Rohimah, there are 2 questions from Bapak Bagus Sumargo and from Prof. Ray Chamber. The question in the chat room, you can read the question or I can read the question for you. Halo, Ibu Siti Rohma. Very upset because the Wi-Fi is not stable. Okay, it's okay. Okay, Bapak dan Ibu, let's go to the photo session. Please turn on your video because we will take a picture. Is it ready? Okay. 1, 2, and 3. Cheers.
Okay.
Once more, we will take the picture. Okay. Everybody, please turn on your video. 1, 2, and 3. Okay. Thank you so much. Okay, Bapak dan Ibu, I think this is the end of our conference, and for all attendants, please fill out the attendance form on the link. You can get the link form at the room chat. I mean chat room. And I will give you 5 minutes to fill the attendance form from now. Don't forget to fill the attendance form, and you can get the link from the chat room. We give you 5 minutes to fill the attendance form. Okay, I would like to remind you once more. Please fill out the attendance form on the link, and you can get the link from the room chat or chat room. I mean chat room. Before we close the conference. Okay, I think all participants already finished to fill the attendance form. Thank you very much for your participation and your contribution. please give applause to all of us, especially for our invited speaker, Prof. Ray, and 6 presenters today.
Thank you.
Thank you so much, Prof. Ray. See you on the next agenda, yeah? I hope so. Okay, see you on the next year, Bapak dan Ibu. And this is the closing video for all of you. Thank you so much. Assalamualaikum warahmatullahi wabarakatuh. See you on the next.
Waalaikumsalam warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Dear participants, this is the end of our conference programs. Please assign your attendee, therefore we can send the souvenir to your address. The certificate of participation is available in your SMIC account only if you present in the conference. We have also chosen the best presenter from each field. We will announce the best presenter name in our website on August 10, 2020. From Santika Hotel Kelapa Gading, Jakarta, thank you for your participation and see you in the 3rd Science and Mathematics International Conference 2022. Assalamualaikum warahmatullahi wabarakatuh.
SMIC 2020!
Dari The Honorable ya berarti? Iya. Diem aja.
Friends, lupa. American Institute of Tourism will do a proofreading. Itu apa ya? Dear participants,